Introduction to Mathematics for Computing, Section 6, Logic. In this section we're going to investigate mathematical logic. We'll commence with an introduction and give some historical perspective on the development of mathematical logic. So in this section we'll have a look at the development of logic in ancient Greek times using the idea of a syllogism. We'll move on and have a look at mathematical statements, and in particular we'll have a look at what are called propositions. Following that we will have a look at logic operations. These are operators that we can apply to propositions, so combining two propositions together using logical operations, can we then create a new proposition? And we will also look at truth tables, which are a way to demonstrate the effect of logical operations on propositions. And finally we'll end with a summary of the topics covered in this section. So let's begin with an introduction and let's have a look at some of the development of mathematical logic in terms of an historical perspective. So if we go back to ancient Greek times and we consider the times of Aristotle, the Greeks were also very interested in the idea of argument and in the logical conclusions or deductions that can be made as part of a logical argument. So one of the ways in which this was formulated in Greek times by Aristotle was through the use of what is called a syllogism. So let's take an example to commence with, and we'll see how this idea of a syllogism can be formulated. So let's start off with two statements. The first statement is that all NCI students are human, which I believe is the case. The second statement we will consider is that all humans are mortal. And the question we then need to ask is, can we reach a conclusion regarding the mortality of NCI students? This is where this idea of a syllogism comes in. So Aristotle would have defined the syllogism in the following way: a discourse in which certain specific things, having been supposed, something different from the things supposed results of necessity because these things are so. So really what that is saying is that we are taking certain statements to be either true or false according to our supposition, and based on our suppositions, logically, can we reach a conclusion? Can we actually create a new statement that is necessarily going to be true based on the initial statements that were either true or false that were under consideration? So in this case, let's break it down and see what conclusion we can reach based on taking these two initial statements as being true. Okay, in terms of terminology with the syllogism, the initial statements are going to be called premises. So in this case we've got two premises. The first premise is that all NCI students are human. The second premise is that all humans are mortal. And based on these two premises we will reach a conclusion. The conclusion in this case is that all NCI students are mortal. Now I would draw your attention to the use of the word all in the premises and also in the conclusion. This word all is in some way quantifying the subject matter of the statement. So we're saying that every NCI student is a human. Every human is mortal. So this word all is quantifying the area of discourse, the subject matter, in some way. Okay, so based on these premises we can see that all NCI students are mortal. So all students are human and all humans are mortal, therefore all NCI students are mortal. This would be the conclusion that is reached using this idea of a syllogism. Let's take another example. In this case again we have two premises. The first premise, all elephants are yellow, and the second premise, all yellow objects are capable of flying. Now, for the sake of argument, we are assuming that the premises in this case are true. So I am assuming, for my argument, that all elephants are yellow. I am also assuming that all yellow objects are capable of flying. take these as given. The fact that they are given then, what conclusion can we reach? Well, in this case, we can apply the same sort of reasoning as in the previous example to come up with a conclusion. The conclusion in this case would be that all elephants are capable of flying. Okay, so we're applying rules of logic to the premises and coming up with a conclusion then. Okay, so logically this argument is sound based on the premises. Now, it is a question that can be argued, well, all elephants are not yellow, and all yellow objects are not capable of flying. But for the sake of the syllogism, we are not so interested in the actual veracity of those statements. For the sake of the argument, the critical point is that we are assuming that they are true. And given that assumption, or those assumptions, we can then reach a conclusion, which would also be true. Okay, so let's take some more premises, and this time please note that the use of the word all has been replaced by the use of the word some. So we're quantifying the subject under consideration here in each of the premises in a different way. We're no longer saying that every elephant is grey, and we're not saying that every grey object is capable of flying. We're restricting in some way the subjects that are under consideration by saying that only some elephants are grey and that only some grey objects are capable of flying. So based on these two premises then, let's have a look at a conclusion. Some elephants are capable of flying. Now, can we say that this conclusion is actually valid based on the two given premises? And the example given here, the conclusion is actually not valid. So some elephants are capable of flying is not a logical conclusion based on these premises. And the key difference here is this use of the word some. Okay, so this quantifier that we're looking at in terms of the subjects that we're considering. So some elephants are grey, we're assuming that is true. Some grey objects are capable of flying, we're assuming that is true. We cannot reach the conclusion then that some elephants are capable of flying. Okay, so think about that for a moment. Just because we said that some elephants are grey, and we've said that some grey objects can fly, we cannot conclude for definite that some elephants are capable of flying. Okay, so the grey objects that are capable of flying, they may not be elephants, even though elephants are grey. So we cannot jump and reach this conclusion based on logic. Okay, so the quantifiers that are used with the premises are going to be of critical importance in reaching these logical conclusions. And we will see that this flows through into modern mathematics as well.